So force is the concept that is central to all discussions of athletics and training. So no matter what the phenomena under discussion, the common currency that we can always reduce everything down to is the amount of force that is produced. The two units that we commonly use to discuss force are going to be the Newton and the pound. Newtons are going to be the metric system, and a Newton is simply 1 kilogram meter per second squared. So all that means is you're accelerating a mass of 1 kilogram at a rate of 1 meter per second squared, and then that's 1 Newton. In an imperial system, we use the pound, and that's equivalent to about 4.4 Newtons. So the main thing to consider is that it takes a lot of force to accelerate a small object to very high rates of acceleration, and likewise it also will take large forces to accelerate very large objects to even small acceleration rates. Now this kind of brings us into, once again, back into force vectors and things like gravity. When we're not in the presence of gravity, let's say we're in deep space, things are just floating around. And if you have two objects, one object has to apply a force to another object in order to make it and cause it to move. That object will apply an equal and opposite force to the other one. So we see this anytime we have to apply force to an object that is moving parallel to the Earth's surface. So whenever we look at motion along the X or the Z axis with this ball, I have to apply a force to make it move, and then once I no longer apply that force, that object will continue traveling in the same direction at relatively the same velocity, minus whatever other forces might act on it, like air resistance. Same thing going in the Z-axis. If we go on the Y-axis, things are always under the force of gravity. So gravity interacts with mass in such a way that the force is always going to be proportional to the mass. So if you have a 1 kilogram object, gravity is going to exert a 9.8 Newton force on that object. If you have a 2 kilogram object, it's going to exert double the force. Now, because gravity is exerting double the force on the heavier object, does not accelerate it twice as fast because the object is twice as heavy. So it takes twice as much force to make that object accelerate at the same rate. So what that means is all objects are going to accelerate at the same rate in a gravitational field, provided there's no other forces acting on those objects. So commonly, the most common of which we see is friction and air resistance. So if you have a very dense object like a rock, you have another object that's not very dense like a feather that's going to have a high amount of drag on it, or it's going to have a high amount of air resistance, the denser object's going to fall faster because the amount of friction that's exerted on the object in proportion to the amount of force exerted on that object by gravity is going to be a lot higher. So the thing with force and gravity is that anytime we want to have an object move at a constant velocity, whether it's up, down, or not moving at all in an up-down direction, we have to apply a force that is equal to that of gravity. So if we have a 100 kilogram object, gravity is exerting 981 newtons of force downwards on it, we also have to exert, and the object is already in motion, let's say it's going downwards at 1 meter per second, we have to also apply 981 newtons of force to maintain the downward velocity of that object at 1 meter per second. If we apply less force than that, the object's going to begin to accelerate. If we apply no force, the object will accelerate at 9.81 meters per second downwards until it hits the ground or something stops it. Likewise, same thing for going upwards. If we have an object going upwards at 1 meter per second, and it's a 100 kilogram object, we have to apply 981 newtons of force to maintain the upward velocity of that object. If we apply less force than that, the object's going to begin to slow down, and eventually it'll stop, and then it'll start to go downwards again. And same thing, to hold an object still, if this ball weighed 100 kilograms, we have to apply 981 newtons of upwards force just to hold it in place. So that's the main takeaway with all discussions of gravity and force, is not so much is always going to be that we have to apply a force equal to that of gravity to maintain a constant velocity, even if that velocity is 0. To accelerate an object upwards, we have to apply a force that is greater than the force provided by that of gravity. To cause an object to decelerate, we have to apply a force that is less than that of gravity. And in terms of linear motion, that's how force works.